Yellowstone Caldera Chronicles is a weekly column written by scientists and collaborators of the Yellowstone Volcano Observatory. This week's contribution is from Lauren Harrison, postdoctoral researcher with the U.S. Geological Survey. Colloidal Pool is a thermal feature in the Porcelain subbasin of Norris Geyser Basin, located just down the hill from Norris Museum. A 1904 historic map does not show a feature where Colloidal Pool now exists, so it must have appeared and substantially increased in size over the last 120 years. Although Colloidal Pool is now a large shallow acid pool, usually with opalescent bright blue water, in the past the feature had spectacular geyser activity characterized by eruption of muddy water as high as 30 meters. The National Park Service, tasked with monitoring the more than 10,000 thermal features in Yellowstone by the Geothermal Seam Act of 1970, has measured the pH, temperature, and electrical conductivity, a measure of water salinity, of Colloidal Pool in 1998, 2018 and 2021. The water temperature and characteristics changed in 2021, including significant cooling and the appearance of foam on the surface of the pool. To investigate the source of these changes, Yellowstone Volcano Observatory scientists took samples of colloidal pool water and solids during a field visit in June 2021. The collected samples indicate that colloidal pool water had high concentrations of sulfate and lower concentrations of chloride, alkalis, silica and trace metals compared to typical neutral chloride thermal waters, like those from Old Faithful. The high sulfate concentrations come from the flux of H2S gas through the pool, which oxidizes to H2SO4 in contact with the pool's water and causes the low pH. This tells us that in June 2021 colloidal pool water has no direct input of thermal water, which is indicated by the low chloride concentrations, but it does have a significant flux of geothermal gases through the pool. The higher temperatures and electrical conductivities observed by measurements in 1998 and 2018 suggest that prior thermal water input did exist into colloidal pool but had ceased in 2021. This shift in water chemistry at a thermal feature is not uncommon and may be a result of the interaction between the level of the water table, amount of boiling of deep geothermal waters, subsurface fluid flow paths, controlled by precipitation of hydrothermal minerals and seismicity, and variable mixing with meteoric or other water types. For example, following the 1959 Hebgen Lake earthquake, Opal Spring changed from a discharging alkaline chloride spring to acid sulfate water. The colloids in Colloidal Pool were investigated using a high-powered scanning electron microscope, SEM, that can produce detailed images of very small particles and provide information on their chemical composition. The colloids sampled in 2021 fall into four main categories: 1. Hydrated silica, 2. Clay particles, 3. Sulfur-rich particles, and 4. Diatoms. Hydrated silica can precipitate at low pH, as observed in Colloidal Pool, although it typically does not form sinter deposits, like those that make up geyser cones, unless the pH of thermal waters is higher. Clays are typical of acid sulfate conditions and form from the reaction of high-temperature acidic thermal waters with rhyolitic volcanic rocks, here the underlying lava creek tuff. Allanite, a sulfur-rich mineral with the formula Cal3SO4 2O6, has been observed in many Yellowstone acid sulfate thermal features and associated clay deposits, and it forms because of the high sulfate concentrations. Diatoms are microscopic aquatic organisms found in almost all surficial earth waters from the ocean to glacial meltwater streams to nearly boiling geothermal pools. The diatoms found in Colloidal Pool belong to the genera Eunotia, which grow in acidic to near neutral waters, pH 3 to 6, in shallow water habitats. Diatom populations have also been documented in nearby Beowulf Spring, pH 50 degrees Celsius, in the 100 Spring Plains subbasin of Norris Geyser Basin. As is common for many thermal features around Norris Geyser Basin, Colloidal Pool had rapid and noticeable changes in activity, pool color and chemistry in 2021. The decrease in water temperature and electrical conductivity indicates a decrease in the flux of thermal water flowing into the pool. This could be due to below average precipitation, which can result in lowering of the water table. This, in turn, could lead to more boiling of subsurface geothermal water. Another possible explanation is that precipitation of hydrothermal minerals in the subsurface caused the closure or shrinking of gas and water pathways, which throttled down the thermal water flow to Colloidal Pool.